Welcome back, everybody, for another deep dive. This time, we're going to be tackling large language models, LLMs. You've probably heard of them.
I would think so, yeah.
They're like the brains behind all those, crazy smart chatbots and the AI writers that are popping up everywhere.
Right.
But what we really want to understand today is how are these LLMs being taught to reason like humans?
Yeah.
Not just like, parrot information, but actually like think things through step by step,
Right.
just like we do. And our deep dive this time is going to be all about this quest for what they're calling large reasoning models.
That's right.
And it might surprise you to know that just making these models bigger isn't enough.
Right.
It's like, thinking a bigger brain automatically makes you smarter.
Yeah. Yeah, it doesn't quite work that way, does it?
It doesn't, know. They need to be trained to think in a much more structured way. So, what are some of the things that we're going to learn today? What should our listeners be excited about?
Well, you'll discover how a simple phrase like, let's think step by step, can actually improve an LLM's problem-solving abilities. We call this chain of thought prompting,
Okay, interesting.
and that's just the tip of the iceberg. You'll also delve into how these models are learning from their own mistakes, with something called reinforcement learning, almost like training a dog with treats for good behavior.
Okay.
Plus, we'll even uncover how giving an LLM more time to think during a task can lead to even smarter answers.
Really?
It's all about making these models think more strategically.
So wait a minute. You're saying that giving an AI more time to think, like to procrastinate, can actually make it smarter?
Yeah, it might sound counterintuitive, but it's true. We'll dive into that.
Okay. All right. Well, I am intrigued. But let's start at the beginning. How do these LLMs typically learn? And why isn't that enough for complex reasoning?
So traditionally, LLMs are trained on massive amounts of text data.
Right.
It's like they're reading the entire internet, absorbing all this information about language and how it's used. This gives them a really broad understanding of language, but not necessarily the logic behind it. They can predict the next word in a sentence, but they may not understand the why or how behind that prediction.
So it's like they're fluent in a language, but they haven't quite grasped like the grammar rules.
That's a great way to put it, yeah.
So how do we take them from just being eloquent speakers to actual thinkers?
Well, we need to break down the concept of thought itself.
Okay.
Think of it as a sequence of tokens. These could be words, symbols, or even concepts that represent the steps in a reasoning process.
Okay.
Instead of just predicting the next word, we want LLM to be able to generate these sequences of tokens
Yeah.
that represent logical, step-by-step thought.
So it's like we're teaching them to think in bullet points almost.
Yeah.
Each bullet representing a distinct step in their reasoning.
That's a great way to put it, yeah.
Yeah.
And the chain of thought prompting technique is a perfect example of this. Just by prompting the model with, let's think step by step, it forces the LLM to break down its reasoning into a series of discrete steps, rather than jumping straight to a conclusion.
And this actually works. They become better problem solvers just by being told to think step by step.
Yeah, it might sound simple, but it has a remarkable impact.
Yeah.
It's like giving the model a framework for its thoughts. Instead of a jumbled mess, it's laying out its reasoning in a way that's transparent
Right.
and often more accurate.
That's wild.
Yeah.
Okay, so I'm guessing there are some challenges in getting these models to consistently reason in this structured way.
Sure.
What hurdles are researchers facing?
You're absolutely right. One major challenge is the sheer volume of data needed to train these models on complex reasoning.
Right.
It would be incredibly time-consuming and expensive to have humans annotate every single step in a complex thought process. Imagine trying to write down every thought you have while solving a math problem. It would be exhausting.
Yeah, no, it would be impossible, I think. So it sounds like relying solely on humans to teach these models how to reason would take forever. So what's the alternative?
Here's where it gets really mind-blowing. Researchers are now shifting from human-labeled data to AI-generated data.
Wait, so AIs are actually teaching other AIs how to think.
Exactly.
Are we talking about like some sort of AI teacher-student scenario here?
Exactly. And it's working surprisingly well. We've got a couple of different approaches.
Okay.
One is using stronger, more advanced LLMs to evaluate the reasoning steps of weaker ones. Think of it like a master chess player analyzing the moves of a novice,
Okay.
providing feedback, and guiding them toward better strategies.
So instead of relying on humans to like meticulously label each step,
Right.
we're letting the AI experts guide the AI students.
Exactly.
That's pretty ingenious.
Yeah.
What other techniques are being explored?
Another technique involves using simulations, essentially creating virtual environments where the LLM can practice its reasoning skills. It's like giving the LLM a playground to test out its thinking abilities and then using that playtime to improve its skills.
I love that analogy. So what kind of simulations are we talking about? How do they actually help the LLM learn to reason?
Researchers are using techniques like Monte Carlo simulations and Monte Carlo tree search, or MCPS.
Okay.
Now, I know that sounds complicated,
Yeah.
but imagine you're playing a game of tic-tac-toe.
Okay.
MCTS allows the LLM to simulate thousands of games,
Okay.
exploring different moves and learning which ones lead to victory. This helps it build a map of successful reasoning paths that it can apply to other problems.
So it's like the LLM is playing out all the possible scenarios in a game,
Right.
figuring out which moves lead to the best outcome,
Exactly.
and then applying that knowledge to other challenges,
Yeah.
even ones that aren't games.
Exactly. And the beauty of this approach is that LLMs can learn from their own mistakes. If a particular reasoning path leads to a dead end in the simulation, the LLM can adjust its strategy and try a different approach.
Okay.
It's a continuous cycle of learning and improvement.
This is all incredibly fascinating, but I'm curious about how these models are actually learning from this data. We've got the AI teachers and the AI playgrounds,
Right.
but what's the actual teaching method? How do they go from making mistakes to improving their reasoning?
That's a great question, and it leads us into the world of reinforcement learning. Think of it like training a dog. You give it a treat for good behavior,
Right.
and it learns to repeat those actions.
Right.
It's the same principle with LLMs, but instead of treats, we use rewards.
So what kind of rewards are we talking about? Are you giving these LLMs like virtual gold stars or good reasoning or something?
Well, it's not quite gold stars, but the concept is similar. There are actually two main types of reward models being used.
Yeah.
Outcome reward models, ORMs, and process reward models, PRMs.
Right.
With ORMs, the model only gets a reward at the very end, based on whether it got the final answer right.
Okay.
This is straightforward for simple problems, but it can be tricky for multi-step reasoning because it doesn't provide feedback along the way.
I see what you mean. If the LLM makes a mistake early on in its reasoning process,
Right.
it might still get the final answer wrong,
Right.
even if the rest of its logic was sound. It's like getting penalized for tripping on the first step of a race, even if you sprinted the rest of the way.
That's a great analogy, and that's why PRMs are so interesting. They give rewards at each step of the reasoning process. This allows the model to learn the importance of individual steps
Oh, yeah?
and refine its reasoning even further. It's not just about getting to the right answer, it's about taking the right steps along the way.
So it's about rewarding the process, not just the outcome.
Exactly.
That makes a lot of sense. But how do we determine what constitutes a good step? Are humans still involved in this reward process?
It can be done with human feedback. But we're also using techniques like those Monte Carlo simulations we talked about earlier. The simulations help determine which reasoning paths are more likely to lead to success, and those steps are then rewarded.
So it's like a feedback loop. The simulations help identify good reasoning steps. Those steps are rewarded. And the LLM learns to prioritize those strategies. It's almost like the AI is developing its own internal system for evaluating its thoughts.
That's a great way to put it. And this brings us to a fascinating and somewhat counterintuitive finding. We can actually improve an LLM's reasoning by giving it more time to think during a task.
Hold on, you're saying that giving an AI more time to ponder, to actually procrastinate a bit, can make it smarter.
It might seem strange, but it's all thanks to those PRMs we talked about. These PRM-guided search algorithms allow the LLM to systematically explore different reasoning paths and evaluate their potential before settling on a solution. Think of it like finding the best route on a map. Instead of just taking the first path it sees, the LLM is using the PRM to explore different routes, considering factors like traffic, road closures, and even scenic views before making a decision.
So instead of just spitting out the first answer it comes up with,
Right.
it's taken the time to consider multiple possibilities
Exactly.
and choose the path that's most likely to lead to success. It's like strategic procrastination for AI. I'm starting to see why you said giving it more time can actually make it smarter.
Exactly. It's
Yep.
all about allowing the LLM to think harder explore different avenues, and make more informed decisions.
And how do these search algorithms actually work? Are there different types?
Yeah.
Because I imagine simply exploring every possible reason path would take forever.
You're right. That's where different types of search algorithms come in. Think of it like having different tools for navigating a complex maze.
Okay.
One tool might be brute force, trying every single path until you find the exit.
Okay.
That's like tree search, which systematically explores every possible reasoning path. But it can be very time-consuming.
I can see why that wouldn't be the most efficient approach, especially when you're dealing with complex problems. So what other navigation tools are there?
Another tool is like having a map with highlighted paths that are most likely to lead to the exit. That's similar to beam search, which focuses on the most promising paths at each step, kind of like narrowing down your search based on the most relevant clues.
So it's like the LLM is prioritizing certain reasoning paths based on its training and the rewards it's received. It's making more strategic decisions about where to focus its attention.
Exactly.
What other tools do researchers have in their AI toolkit?
Well, imagine you're in that maze and you have a special compass that lets you peek ahead and see which paths are dead ends.
Okay.
That's kind of like look-ahead search,
Hmm.
which uses the PRM to simulate steps ahead, allowing the LLM to make more strategic decisions about which paths to pursue.
This is all incredibly insightful. It sounds like we're on the cusp of some major breakthroughs in artificial intelligence with these advanced reasoning techniques.
We are indeed. And speaking of breakthroughs, there's a specific model developed by OpenAI that embodies many of these advancements, O1. This model represents a significant milestone on the path towards large reasoning models.
Okay.
Because it's not just large, it's been specifically trained to reason using many of the techniques we've been discussing.
Okay. I'm really intrigued now. So O1 is like the poster child for all of these advancements in LLM reasoning.
You could say that, and what's remarkable is that O1 exhibits several key traits that showcase its advanced reasoning abilities. For one, it's amazing at integrating knowledge from different areas to solve complex problems.
So it's not just memorizing facts,
Yeah.
it's understanding how those facts relate to each other
Right.
and using that understanding to draw conclusions and solve new problems. That's
Right.
a whole different level of intelligence. What else makes O1 so special?
Well, it's incredibly good at breaking down large problems into manageable steps. This systematic problem decomposition is something we humans do naturally, but it's been a challenge to replicate in AI.
It's like O1 is capable of taking that let's think step by step, prompt to heart, and actually applying it in a meaningful way. Anything else? Because I'm already super impressed.
Perhaps most importantly, O1 consistently exhibits reliable and coherent reasoning, even when faced with challenging tasks.
Yeah.
It doesn't just have flashes of brilliance, it demonstrates a consistent ability to apply logical thinking.
So it's not just about being smart, it's about being consistently smart.
Exactly.
It sounds like O1 is setting a new standard for LLM reasoning.
It certainly is. And you know what's even more exciting? Researchers have found that O1 actually gets better at reasoning the more time it's given to think. It's like a scaling law for reasoning. The more it thinks, the better it gets.
That's incredible. It sounds like O1 is living proof that sometimes a little bit of procrastination can actually lead to better outcomes even for AI. But I'm guessing O1 being developed by OpenAI is not open source, right?
You're right, it isn't. However, there are several exciting open source projects out there that are trying to replicate O1's capabilities, each with its own unique approach.
Oh, that's fantastic news. It's so important for these advancements in AI to be accessible to everyone. What are some of these projects that are making waves in the open source world?
One notable example is OpenR, which focuses on recreating OpenAI's training methods using those PRMs we discussed. It's like they're trying to democratize access to the technology behind O1, making it available to researchers and developers worldwide.
That's amazing. What other open source projects are out there pushing the boundaries of LLM reasoning?
Another fascinating project is REST MCTS. This one integrates data collection and model training in a continuous loop, allowing the model to constantly learn and improve. Imagine an AI that's constantly refining its reasoning abilities based on new information and experiences.
So it's kind of like a self-learning AI system. That's incredible. Are there any other notable open source efforts?
Definitely. There's the O1 Replication Journey project, which emphasizes structured training with trial and error learning. It's much like how humans learn through experience, constantly making adjustments based on feedback and outcomes.
I really like that approach. It seems more natural and intuitive. It's like the AI is learning through exploration and experimentation, just like we do. Any others?
Absolutely. There's Llama Berry, which is notable for its use of a pairwise preference reward model. This means it's not just being rewarded for correct answers, it's also being rewarded for choosing better reasoning paths over less effective ones. It's like a refinement process that helps the AI develop a more sophisticated understanding of which strategies are most effective.
It sounds like the open source community is really stepping up to the plate and pushing the boundaries of LLM reasoning.
They are indeed, and this is just the beginning. The future of large reasoning models is incredibly bright, with endless possibilities. But let's take a step back and consider what all of this means for us, for humans.
I'm already feeling a little mind blown by everything we've covered so far, but I'm definitely eager to explore the bigger picture and understand the implications of all these advancements. Where do we go from here?
Well, if these models are getting so good at reasoning, it begs the question, what does this mean for human intelligence and problem solving?
That's a deep question and one we'll definitely need to explore further. I'm already sensing a whole new set of questions and possibilities emerging. But for now, I think it's time to take a break and let our listener absorb everything we've covered in this first part of our deep dive.
Sounds good to me. We've covered a lot of ground, and there's much more to explore. We'll be back soon to continue our journey into the fascinating world of large reasoning models. Welcome back. I hope you've had a chance to ponder some of those big questions about AI and human intelligence. It's a lot to unpack.
It really is. We've explored how LLMs are learning to reason.
Right.
But now I'm curious about another essential aspect of intelligence, the ability to evaluate information
Right.
and understand its implications.
Yeah.
Is that something AI is getting better at as well?
Absolutely. It goes beyond simply knowing facts. It's about understanding the why behind them and using logic to connect the dots. Think of it like the difference between reading a history book and truly understanding the cause and effect behind historical events.
Okay. I'm starting to see the distinction. So are we talking about teaching LLMs logic?
Yes.
Like those classic if A, then B scenarios?
Exactly. We're talking about logical reasoning.
Yep.
And it's a crucial step towards creating AI that can truly interact with the world around it
Okay.
in a meaningful way.
So how are researchers approaching this? Are there different types of logical reasoning that LLMs need to master?
There are indeed. We've got deductive reasoning, inductive reasoning,
Okay.
and abductive reasoning.
Okay. Those sound pretty intense.
Yeah,
Can you break them down for us, maybe with some real-world examples?
of course. Let's start with deductive reasoning. It's the classic. If A equals B and B equals C, then A must equal C type of logic.
Mm.
LLMs are being trained to make these kinds of deductions with remarkable accuracy.
That's impressive. It's like teaching them to solve those logic puzzles we used to do as kids.
Right.
What about inductive reasoning? How's that different?
Inductive reasoning involves making generalizations based on patterns you observe.
Okay.
Like if you see a bunch of swans and they're all white, you might conclude that all swans are white.
Ah, I see. It's about making educated guesses based on the information you have.
Right.
Of course, as we know, not all swans are white.
Right.
So it's not a foolproof method, but it's still a powerful way to learn about the world.
Precisely. And LLMs are being trained to use inductive reasoning to make predictions, identify trends, and even come up with new ideas based on the patterns they observe in the data.
That's pretty incredible. It sounds like we're teaching them to think more like scientists.
Yeah.
Observing, hypothesizing, and drawing conclusions. What about that last one you mentioned? Abductive reasoning.
Yeah.
What's that all about?
Abductive reasoning is all about finding the best possible explanation for a set of observations, especially when we don't have all the information. Think of it like this. You hear a noise outside your window at night.
Okay.
Could be the wind, could be a raccoon, or maybe even a burglar.
Right.
You're using abductive reasoning to come up with the most likely explanation based on the limited evidence you have.
Okay, that's a great example. It requires not just logic, but
Yeah.
also like an understanding of the world
Right.
and the ability to consider multiple possibilities. That sounds like a tall order for AI, even with all these advancements.
That's definitely challenging.
Right.
But researchers are making progress. Abductive reasoning is crucial for AI systems that need to make sense of complex, real-world situations, where there's often missing information or ambiguity.
It makes me think of those detective shows where they have to piece together clues and come up with the most plausible scenario.
Right.
It's like we're training LLMs to be AI detectives.
I like that analogy. And as these LLMs become more adept at these different types of logical reasoning, it opens up a whole world of possibilities in fields like scientific discovery,
Hmm.
healthcare, and even creative writing.
I can definitely see how logic would be essential in all those fields.
Yeah.
But let's shift gears a bit and talk about something that we humans often take for granted: common sense.
Right.
Is that something we can teach to an AI?
Yeah.
Because it seems like common sense is more about unspoken rules and intuition
Right.
than it is about hard logic.
You've hit on a crucial point.
Mm-hmm.
Common sense is one of the biggest challenges in AI research.
Right.
It's not just about knowing facts, it's about understanding the nuances of the world.
Yeah.
The unspoken rules.
Right.
The things that seem obvious to us, but might not be to an AI.
It's like knowing that you shouldn't put a metal fork in a toaster, or that it's generally a bad idea to jump out of a moving car.
Right.
Things that seem so basic to us humans.
Exactly. And teaching that to an AI is incredibly complex.
Yeah.
Because common sense isn't explicitly written down in any textbook.
Right.
It's learned through experience, observation, and social interaction.
So how are researchers trying to crack the code of AI common sense?
Yeah.
Are they feeding these LLMs some sort of encyclopedia of common sense?
Well, it's not quite that simple. But they are training LLMs on massive data sets of text and code
Okay.
that contain examples of common sense reasoning. The idea is that by exposing these models to vast amounts of data
Mm-hmm.
that reflect how humans think and act, they might be able to glean some of those unspoken rules.
So it's like they're learning through osmosis by observing millions of examples of human behavior
Right.
and trying to extract the underlying principles.
Right.
Are there any other techniques being used?
One interesting approach involves using prompts to guide the LLM's reasoning. Instead of just asking a factual question,
Okay.
researchers might present the LLM with a scenario that requires common sense to navigate.
So instead of asking, what is the capital of France,
Great.
they might ask, if you were planning a trip to Paris, what's the first landmark you would visit?
Right. That forces the LLM to think beyond just facts
Right.
and consider context and common sense.
Exactly. It's a clever way to assess whether the LLM is actually understanding the world, not just parroting information.
That's really fascinating.
Yeah.
But how do we actually measure common sense in AI? Is there some kind of standardized test for AI common sense?
Yeah.
I can just imagine an AI like sweating over a multiple choice exam on basic human behavior.
There are actually several benchmark data sets
Yeah.
and tasks designed specifically to evaluate common sense reasoning in AI. One example is Common Sense QA, which is a multiple choice question answering task, where the correct answer requires common sense knowledge.
So questions like, what should you do if you find a lost wallet?
Right.
Or why shouldn't you eat food that's fallen on the floor?
Yeah.
I love it. It's like we're finally able to test AI on its understanding of those everyday unwritten rules that we humans often take for granted.
Precisely. And these benchmarks are becoming increasingly sophisticated.
Challenging LLMs to understand nuances of language, social interactions, and even physical reasoning.
This is all so impressive, but it's making me wonder about the bigger picture. If AI can reason logically, understand common sense, and even learn from its mistakes, what does that mean for the future of work? Are we headed for a world where robots take over all our jobs?
That's a question on a lot of people's minds these days. While it's impossible to predict the future with certainty,
Right.
one thing is clear: AI is going to play a significant role in shaping the future of work.
Yeah. I think it's safe to say that some jobs will become automated
Right.
as AI and robotics advance. But I'm curious to hear your perspective on this. How do you see AI impacting the workforce?
Well, it's important to remember that AI is not meant to replace human workers entirely. Instead, it's more likely to augment our abilities and help us to be more productive and efficient. AI can take over repetitive or dangerous tasks, freeing us up to focus on more creative, strategic, and interpersonal aspects of our work.
That makes sense. It's like AI can be a powerful tool to enhance our capabilities and create new opportunities. But I imagine this shift will require us to adapt and develop new skills to thrive in a world where AI is more integrated into the workplace.
Absolutely. We'll likely see a growing demand for skills that are uniquely human and difficult to replicate in AI, such as critical thinking, creativity, empathy, emotional intelligence, and complex problem solving.
It's almost like AI is pushing us to become more human, to focus on those qualities that truly set us apart. It's an exciting but also challenging prospect.
I agree. Instead of fearing the rise of AI, we should view it as an opportunity to redefine the nature of work and create a future where humans and AI can collaborate to achieve incredible things.
I love that perspective. It's not about humans versus AI, but humans with AI. It's about finding ways to leverage the strengths of both to create a more innovative and equitable future.
Well said. And as we navigate this new landscape, it's crucial to keep the ethical implications of these advancements at the forefront of our minds. We need to ensure that AI is developed and used responsibly, and that it benefits all of humanity, not just a select few.
That's a crucial point. It's not just about technological progress. It's about ensuring that progress aligns with our values and contributes to a better future for everyone.
Exactly. But for now, let's dive into another area where AI is making waves: coding. You've probably heard about how AI is being used to generate code, but let's explore the specific benchmarks and tasks involved in this rapidly evolving field.
I'm all ears. I've heard bits and pieces about AI coding, but I'm eager to get a clearer understanding of how it works and what the implications are.
Well, there are several benchmarks specifically designed to evaluate how well LLMs can generate code. One example is ODX, which stands for an Open Domain Execution-Driven Evaluation of Code Generation. It focuses on ensuring that the code generated by AI actually works as intended. They run the code to see if it produces the correct output, which is a pretty crucial step.
That makes a lot of sense. It's one thing to generate code that looks good on paper, but it's another thing entirely to ensure it actually functions correctly in a real-world environment. What other benchmarks are there?
Another one is SWE Bench, or Software Engineering Benchmark. This one's really interesting because it uses real GitHub issues to test the AI's ability to solve real-world coding problems. So it's not just about writing code in a theoretical sense. It's about demonstrating that the AI can actually apply its skills to real-world challenges faced by developers.
That's really cool. So it's like we're not just teaching these LLMs to code, we're teaching them to be problem solvers.
Exactly.
Are there any benchmarks that focus specifically on data science?
Yeah,
Because that seems like a natural fit for AI.
you're right. Data science is a prime area for AI applications. And there's a benchmark called DS1000, which stands for Data Science 1000. It features a collection of real data science tasks, testing the AI's ability to handle complex data manipulations and analysis.
It's like we're giving the AI a crash course in data science
Yeah.
and seeing how well it can apply its newfound knowledge to real-world data sets.
Exactly. And as data science becomes increasingly important in virtually every industry, the ability for AI to assist with these tasks is going to be incredibly valuable.
I'm already imagining the possibilities. But before we get too carried away with all these specific benchmarks, I want to step back and remember that AI is more than just a collection of algorithms and data sets. It's about creating intelligent agents that can interact with the world around them.
That's a crucial point. To truly gauge the potential of AI, we need to go beyond these isolated tasks
Right.
and create benchmarks that assess how well AI can function as an independent agent in a dynamic environment.
Okay. I'm intrigued. What do these agent-based benchmarks look like? How do you create a test for an AI agent?
Well, it involves creating virtual environments where the AI agent can interact with a simulated world. These environments can range from simple games to complex simulations of real-world scenarios.
So kind of like giving the AI a digital playground to test out its skills
Right.
and see how well it can navigate and solve problems in a more dynamic setting. I like it. What kind of skills are these agent-based benchmarks designed to evaluate?
They assess a whole range of capabilities, including decision-making, planning, problem-solving, and even social interaction. We're looking at how well the AI can adapt to changing circumstances, make strategic choices, and achieve its goals within the constraints of the environment.
That's amazing. It sounds like we're creating AI agents that are becoming more and more versatile and adaptable. Can you give us some specific examples of these agent-based benchmarks?
Of course, one notable example is WebArena, which provides a practical web environment where AI agents can be tested on their ability to navigate websites, extract information, and interact with web elements. Imagine an AI that can browse the web, find the information you need, and even complete tasks online. That's what WebArena is designed to test.
So it's like evaluating how well the AI can function as a digital assistant
Right.
or a web researcher. It's becoming more and more like those AI companions we see in sci-fi movies. Are there any benchmarks focused on e-commerce?
Yeah.
Because that seems like another area where AI could have a huge impact.
You're right. There's a benchmark called WebShop,
Okay.
which simulates an online shopping environment. The AI agent has to browse products, compare prices, add items to a shopping cart, and even go through the checkout process.
Yeah.
It's a great way to test the AI's ability to understand product descriptions, make purchasing decisions, and navigate the complexities of online transactions.
That's incredible. It sounds like these agent-based benchmarks are really pushing the boundaries of AI research and helping us to create more robust and versatile AI systems.
They are indeed. And as these benchmarks continue to evolve, they're playing a crucial role in shaping the future of AI development. We're moving beyond simple tasks and into a realm where AI agents are becoming more independent, adaptable, and capable of interacting with the world in increasingly sophisticated ways.
This is all so fascinating, but I think we've covered a lot of ground in this second part of our deep dive. It's amazing to see how far AI has come in such a short time.
It really is. And I'm sure our listener is eager to hear how this journey continues. We'll be back soon for the final part of our exploration into the world of large reasoning models.
Welcome back to the final part of our deep dive into the world of large reasoning models. We've covered a lot of ground in this series, from those, clever prompting techniques to those AI agents navigating simulated online shopping malls. It's pretty mind-blowing.
It's been quite a journey. And we've seen how researchers are pushing the boundaries of AI, teaching these models to think logically, make sense of the world, and even write functional code.
Yeah. I'm honestly blown away by the progress that's being made. But as we wrap up our exploration, I think it's important to kind of zoom out a bit and consider the bigger picture. What does the rise of these incredibly capable AI systems mean for us as humans?
That's the million-dollar question, isn't it?
Yeah.
It's both exhilarating and a bit daunting to think about the potential impact of these advancements.
I'm feeling both of those things right now. On the one hand, it's incredibly exciting to see what these AI systems are capable of.
Right.
But on the other hand, I can't help but wonder about the potential downsides.
It's natural to have those mixed feelings.
Mm-hmm.
It's important to remember that technology is a tool. And like any tool, it can be used for good or for ill. It's up to us as humans to guide the development and application of these powerful AI systems in a way that benefits society as a whole.
Yeah, that's a really important point. We can't just sit back and let the technology dictate the future. We need to be actively involved in shaping that future, ensuring that AI is aligned with our values and serves humanity's best interests.
Absolutely. And that means having open and honest conversations about the potential risks and benefits of AI, addressing concerns about bias and fairness, and working together to create a future where AI enhances our lives without undermining our values or exacerbating existing inequalities.
It sounds like we need kind of like a roadmap, a set of principles to guide us as we navigate this, uncharted territory.
I agree. We need to be proactive in establishing ethical frameworks for AI development and deployment, ensuring transparency and accountability, and fostering a sense of shared responsibility for the future of this technology.
This all makes me think back to something you said earlier about AI pushing us to become more human,
Right.
to focus on those qualities that truly set us apart. Maybe this is an opportunity not just to advance technology, but to advance ourselves as well.
I think you're onto something there. As AI takes on more tasks, it frees us up to focus on those uniquely human aspects of life: creativity, empathy, compassion, and our relationships with one another. It's a chance to rediscover what it means to be human in a world increasingly shaped by intelligent machines.
It's a profound shift, and it's one that will require us to adapt, to learn new skills, and to reimagine the possibilities for our lives and our work.
It's a challenge, but it's also an incredible opportunity. We're living in a time of unprecedented technological change, and it's up to us to shape that change in a way that creates a more just, equitable, and fulfilling future for all.
Well said. I think that's a perfect note to end on. We've covered a lot of ground in this deep dive, but one thing's clear: the future of AI is full of potential, both for amazing advancements and for ethical challenges.
It's a future we're creating together, one step at a time. And by staying informed, engaging in these conversations, and being mindful of the broader implications, we can help ensure that AI empowers us, not defines us.
That's a powerful message. So to our listener, we encourage you to keep exploring the fascinating world of AI. Keep asking questions, and stay engaged in the ongoing conversation about how we can shape the future of this, transformative technology.
Until next time, keep those minds curious and never stop diving deep.